right, we are looking at mechanical advantage. Machines were invented to make life easier for us. So we wanted to make the work that we do easier, so we make a machine. A machine can make work easier by increasing the amount of force that you exert on an object. The mechanical advantage of a machine is the amount by which a machine can multiply a force. That is why this is also referred to as force ratio. So what do I mean by this? I mean the amount of force that I am putting in is going to be lessened. That is going to be the input force. So the amount of force that I applied to the machine is called the input force. And then the amount of force that the machine applies is called the output force. Okay, so hopefully the machine is putting in enough force of that output force that it makes my work a lot easier. So the input and output forces are measured in what is called newtons. All right, so what is a force in physics? Okay, so if I'm thinking about that, in physics, a force is any interaction that when opposed will change the motion of an object. A force can cause an object with mass to change its velocity. So that's speed and movement. Now, a force can also be described as a push or a pull. So if we're looking at this, the force is going this direction, right? The skier is not being pushed, but gravity is pulling the skier down. Gravity is also pulling the skydiver down. Drag from the air is pushing up into the parachute and slowing you down. This man is pushing, obviously, magnet is pulling, the spring is pushing, right? And so we have that push and pull force movement. It is measured in SI. SI means System International or International System, and that's using the metric units, okay? The unit is that it's being measured in is newtons and represented by force. And now if I'm thinking of newtons as the measurement, it is represented by the symbol N, but force is represented by F. All right, so what is a newton? A newton is just a measurement, right? So it's a unit of measurement for force. And it was named after Sir Isaac Newton, the great scientist who studied force and motion. And we know that from a previous video, they didn't do this all by himself, but he was given the credit. 1 Newton is equal, so 1 Newton is equal to the amount of force exerted by Earth's gravity. So the force exerted by Earth's gravity. So I'll just put gravity, right? On a mass of about 100 grams. All right, so these are just 2 looks at spring scales. These are what we'd be using in school to measure force if we were able to do that. This would hook on something so that it stayed stationary, and then you could hook something on here, like a big pail or something or whatever, and you would measure that force going down. Now, if this was going down here, you could also measure in grams. This is also how the spring scales work in the grocery store. Okay, and here is 25 newtons. So if I went there, if I'm looking at this one and I go to here, that would be 6 newtons. All right, so force, we already know is measured in newtons. This is a lever. Here is the fulcrum. This is the pivot point. Right, and notice the lever on this side is much longer than this side, okay, because this is going to let me to use less force. If the lever was only this long and this went way over here, I'd have to apply a lot of force. So the force, when this side is smaller, the output force is going to be bigger than the input force. So if I planted my butt on here and forced this lever to go down, okay, say that was 25 newtons of force, this would probably be more like 200 newtons of force being provided by the machine. All right, and then the mechanical advantage. Now, this is newtons, this is newtons. Mechanical advantage does not have a unit of measurement. So these, because we're dividing, would cancel each other out. Okay, so the output force here would be 200 newtons. The input force here would be 25 newtons. These cancel each other out, leaving no unit. And you're just saying what the mechanical advantage is in a number, okay? And that would be, for this, 8. The mechanical advantage is 8. All right, so there's 3 problems in a row here. I'd like you to do them. Just like in math, pause the video, please do these, and then come back. All right, so I'm going to pull a weed out of a garden. The mechanical advantage. I apply a force of 50 newtons, which goes on the bottom there, to the shovel. The shovel applies a force of 600 newtons to the weed. Okay, so the mechanical advantage there is going to be 12. All right, to pry open a soda can lid, you apply a force of 50 newtons to a car key. The car key applies a force of 390 newtons to the lid. What is the mechanical advantage? So please pause the video and then come back to check your answer. So that'd be 50 newtons. This would be 390. All right, so this would be 7.8. And remember, the units cancel each other out. All right, to pry a wooden board off a tree house, you can apply a force of 50 newtons to a lever. The lever applies a force of 750 newtons to the board. What is the mechanical advantage of the lever? So please pause the video again. All right, so to do this, again, you set up the problem, and 750 divided by 50 is 15. So the mechanical advantage is 15. Okay, so the mechanical advantage is actually the force ratio, right? The ratio of forces in the mechanical device. For this reason, I can... mechanical advantage is also called the force ratio of the machine. Now, when we're thinking about mechanical advantage, we're thinking, and we're using the formula for mechanical advantage, we are not considering friction. So we are considering the best case scenario that we have a perfect system with no friction. All right, so friction is the force that resists the motion. And I can reduce the amount of friction that can be impeding the force of the push. So if this wasn't a really bumpy, it's not going to glide very easily, and I would have to put more force in here. So the input force would be greater, the output force would be less. But if I sand this down and make it as smooth as possible, or it's on ice, this output motion is going to be greater than the input motion. All right, and that is it for today.